So this is a P chart problem. An attribute control chart needs to be developed for the accuracy of meter readings using Wi-Fi meter readers. So 12 samples were taken, each containing 250 readings. And each sample, how many erroneous readings were there? Okay. So we can compute P for each sample. Okay, 15 out of 250 gives you 0.060. 12 out of 250 gives you 0.048. 19 over 250 0.076. 2 out of 250 is 0.008. 19 out of 250 is 0.076. 4 out of 250 is 0.016. 24 out of 250 is 0.096. 7 out of 250 is 0.028. 10 out of 250 is 0.04. 17 out of 250 is 0.068. 15 out of 250 is 0.060. 3 out of 250 is 0.012. Next we'll compute P bar. P bar, okay, you need the total here, and that is equal to 147. Okay, remember n is equal to 250. So that's given here. So you get 147, 250 observations in each of the 12 samples. So this gives us 0.049. Then sigma sub P bar is P bar times 1 minus P bar over n, and that is equal to 0.049 times 1 minus 0.049 divided by 250, and that is 0.01365. Okay. Now by default use z equal to 3. If it is not stated, then you assume 99.73% and use 3. So remember, the formula is P bar plus or minus z times sigma sub P bar. Okay. So z times P bar is 3 times 0.01365, and that is equal to 0.04095. So lower control limit for P is P bar minus z times sigma sub P bar. So that is 0.01365 minus 0.04095. That is equal to 0.00805. Upper control limit is P bar plus z times P bar 0.01365 plus 0.04095, and that is 0.08995. Then you plot, and I've already prepared the plot here. So you have that is P bar 0.049. That is the lower control limit for P is 0.00805. That's the upper control limit for P, which is 0.08995, and these are the plots. And here this indicates, so this is outside upper control limit. The process is not in control. One more P chart problem. So based on samples of 20 IRS auditors, each handling 100 files, we find that the total number of mistakes in handling files is 220. So here the summary information is given. So it's like we have "20 samples were taken, okay, each 100, and then the number of errors, that sum is 220. So we do not have the individual values of the proportion. So here total number of mistakes is 220. Sample size n is 100. So P bar is 220 divided by sample size of 100, 20 samples. So that gives us 0.11. And then sigma sub P bar will be 0.11, 1 minus 0.11, divided by sample size is 100. Okay, not 20. 20 is number of samples, and that value is 0.03129. So now we want 95.45 limit. So for 95.45% limits, Z is 2. So lower control limit for P is 0.11 minus 2 times 0.03129, and that is equal to 0.047, and upper control limit for P is 0.11 plus 2 times 0.03129, and that is equal to 0.173.